here has been personally victimized by statistics? I 100% have, so let's go over descriptive statistics from the very beginning. I've gotten so many messages of people asking how to explain statistics. What are statistics? What do I need to know? What do I not need to know? I'm confused. Send help. I got you. I felt the exact same way. I actually had an interview when I was applying for internships that asked me a bunch of statistics questions, and I was like, no, I don't know the answer. So I did not get that job, but alas. If you are also struggling in statistics, leave it in the comments and I will try to answer as many questions as I can or make more videos on frequently asked topics. So why do you even want to learn statistics in the first place? The main reason is to tell you what your data is doing. You can't know what to do with it unless you understand what you have. So descriptive statistics is what you usually will do before you do anything with your data, just to understand the data distributions, if there's any skew, if there's bias, mean, median, mode, classic descriptive statistics. You want to understand your outliers. You might do some quartiles, some binning, some visualizations. That is all encompassed in descriptive statistics. The second part of statistics is happening usually around like experimentation, A/B testing, understanding how an experiment is affecting your data and whether or not what you're testing, your hypothesis, is going to have an effect on whatever you're testing it against. So we won't cover those types of statistics today. We're going to focus on descriptive, understanding what your data is looking like. So let's begin. I'm sure you've heard of the mean, the median, the mode perhaps. So for the very baseline, the mean is the average. Of all of the things that you have to look at, your data points, the mean is the average. So you take all of them, you sum them together, and you divide by the number that you have. Simple enough. The mean is important, but it does account for your outliers, which you may or may not want to account for. So the next best thing you can use is the median, which is the middle number. So if you line everything up in order of smallest to largest, the middle number, when you go like that, the middle number is the median. So that can give you more accurate description or understanding of your data. If you have a lot of outliers, say you have like numbers 1 through 10, and then you have 100, the average of those numbers is going to be drastically higher than the representation of your data. So that's why you want to use that. And then the mode is the most frequent. So if you have 1, 2, 2, 2, 2, 2, 3, the mode is 2, the most frequent. And that's important for like imputing when you are trying to fill in the data that is zeros. So the next thing that we are going to talk about on top of mean, median, and mode would be quartiles, percentiles, just binning your data or creating buckets of your data based off of its position against other data points in your data set. So what's important to know about quartiles, percentiles, is that you want to bin them by quantity, but that doesn't mean that the range is going to be the same. So you will bin them to collect, 10 entities, but the 10 entities might span 100 numbers, a range of 100 numbers, 0 to 100, and then the next bin might only be 10 numbers. It just depends on the density of the data within those bins. With your data distributions, there are a whole host of them. There's normal, there's binomial, there's Poisson, there's Bernoulli, my goodness. And all of those have significant meaning in statistics, but as a data scientist, you don't really need to know all of those things unless you're really deep in the research and you need to kind of model a lot more intensely. But what we do use them for is for understanding skew and bias and kind of things we need to correct in the modeling experience so that your model is not overfitted to just your specific set of data and will actually capture the trends as a whole. This is why it's important to calculate things like skew and correlation and things like that, just so that you can account for those in your future engineering process and do your best to cancel those out or come up with new data to counterbalance the principles of the data that we are seeing. I know statistics can be very confusing, and this is just scratching the surface of some of the questions I'm sure you have. Leave any questions in the comments below and I'll be happy to answer those. Follow along for more content like this. Bye.